All right, welcome back, Algebra 1 students. Time now to go over section 7.4 in the exponent chapter. And this is another shortcut rule that actually is grounded in a prior rule, but this is how to divide when you have the same bases. A nice little shortcut for how to simplify your exponent rules. So right in front of you here is actually the simplified version of the rule. If your bases are the same and you're dividing, which mathematically speaking, division is one of those not official operations because it doesn't qualify. It's not commutative, but we can call it division, but we typically have it expressed in a ratio form, and we'll still refer to it as division. That's how most algebra books do it. In more advanced math, we get away from that. But the rule is, if your bases are the same, you can subtract your exponents, but what you want to notice here is that it's m minus n is the rule here. It's the numerator minus the denominator. And in reality, what you're doing is taking advantage of the rule of negative exponents. You're taking the denominator and moving it to the numerator, and you're actually then applying the multiplication rule where you add your exponents. So this is again a shortcut version of prior definitions. Another thing to keep in mind, it's not stated in your text this way, but it's also true that if you wanted, you could subtract the exponent, you could subtract the numerator from the denominator and move this all to the denominator. Now this will all make sense here when we run through some examples, but this is the basic rule. And then I'll show you another way to apply this. So just look at multiple examples. There's very few topics in math, especially Algebra 1, that require the volume of practice that exponents do because there's so many little twists and turns and little nuances. But let's just look at a few examples and see how we do here. So let's look at this first one here, the basic rule that is x to the fifth over x squared. Well, if we apply the rule, we say, oh, well, it's going to be the exponent in the numerator minus the denominator, so 5 minus 2 is equal to x cubed. But there's another couple ways to look at this. So one of the other ways to look at this is you could have said, well, could I just expand the numerator? Could I have just expanded that to be, and I'm going to leapfrog over my final answer and say, could I have just went x times x times x times x times x? Could I have expanded that 5 times? Yes, you could have. And could I have expanded the denominator twice? Yes, you could have. And in reality, you're saying, I'm going to cancel these factors or reduce the factors. I'm going to knock out these two with these two, and I'm just left with x times x times x, which would be x cubed if we were to apply the multiplication principle. So that's another explanation as to why this works. So that seems simple enough, and we could apply that in multiple settings. So let's take a look here. What if, though, the exponent in the denominator was the larger one? And this is the first place where it starts to get a little bit weird, and you're thinking, well, how should I actually be doing this? Well, I'm going to apply the rule as written here, not counting my little extra explanation to the right. So let's just look at it. I say w cubed over w to the third. Well, according to the rule, it should be the denominator exponent subtracted from the numerator. So this would be w to the third minus w to the seventh, and we would get w to the negative 4. And you immediately think, well, I don't like that. I want a positive exponent. So you would move it back down to the denominator and do w to the fourth. And you might be thinking, that seemed like kind of a little extra step. I don't know, it just seemed weird to do it that way. So something to keep in mind that by the time you get to 7.4, some interesting things start happening to you. And because this rule overlaps with negative exponents, it results in many approaches to these questions. And so I'm going to look at several examples, and we'll run through some, and we'll see what you think. So I'm going to show you how I actually do this a little bit differently than this rule, and this might help you, just help clarify it. So here's how I like to look at it. What I like to do is this. The other approach that I use is to ask yourself, where is the exponent bigger? And then just go to that place and subtract. Very simple. So I'm going to go back to our first two examples here. And here's what I mean. It's x to the fifth over x squared. So I say to myself, where is the exponent larger? Well, the numerator. Then that's where I'm going to do my subtraction. And I will subtract the denominator from the numerator, and I have x cubed in the numerator. That's where my final answer will be. Whereas, look at the second example. Where is the exponent bigger? Well, it was bigger in the denominator. So I actually would not have done it this way. I actually would have leapfrogged this. I'm going to leapfrog my answer again, and I'm going to say, what I would have done instead was I would have said, well, I'm just going to draw a line here. I would have said, well, it's bigger in the denominator. So that's where I would have done my subtraction. And I would have said, oh, well, this is 1 over w to the 7 minus 3, and that equals 1 over w to the 4th. That's how I would have gotten it. So I actually would have been applying this little part right here. And it just so happens on this one, it's larger in the bottom, so I still get a positive exponent. Now, if you'd like to move them up and then move them down, you wind up discovering that there are so many different ways to express rational expressions in the numerator, denominator, positive exponents, negative exponents. There's an infinite number of combinations in reality. But in general, the rules are, unless otherwise stated, most of the time we want the answers written with positive exponents. There will be times you might have a worksheet that's stressing or an assignment that's stressing. They want to see if you know the rules, and they'll say, write your answer with every value in the numerator. Sometimes that's the way they'd want it, and actually in this one, w to the negative 4. So the instructions take priority, but unless they're expressed in the instructions, in general, we like our exponents to be positive. So let's take a look at this problem and show you the multiple ways to do this. And so I'm going to approach, but I'm going to use this approach. I'm just going to ask myself, where is it larger, and I'm going to do the subtraction. So if you'll notice, I have A, B's, and C's in the numerator and the denominator. And instead of subtracting, actually I think we'll just do this both ways just for the heck of it. I'm going to do this following the strict rule. So we'll be little rule followers. And we'll say, okay, I'm just going to move everything to the numerator, and I'm going to follow the rule. So that means this would be A to the 2 minus 3, B to the 5 minus 2, and C to the 1 minus 4. And then we would simplify that, and we would say, well, it looks like we get, looks like this is going to equal, if we have enough room here, looks like this is going to be A to the minus 1, and then it's going to be B cubed, and then C to the negative 3. And then if this was an acceptable answer, that's fine. If they said write this with only positive exponents, then you would move the 2 negative exponents to the denominator. And your final answer, you would say, well, I'm going to leave B cubed in the numerator, and then I'm going to move A, C cubed below, and there would be your final answer. Okay? But where I prefer to do it is I like to look at it this way, and I just say, well, okay, I'm going to look here at my 2 A's. I'm going to say, where are they bigger? The denominator. And so I'm just going to say, all right, they're bigger in the denominator, so this is going to be A to the 3 minus 2. So I would look at it. Then I would look at the B's. And I'd say, all right, the B's, bigger in the numerator. So I would say B to the 5 minus 2. Okay? And then I would come to my C's, and I'd say C bigger in the denominator, and this is going to be C to the 4 minus 1. Okay? And then I would clean up my final answer, and I'd say it looks like it's going to be B cubed in the numerator. Denominator becomes A, C cubed. And you can see, you get the same answer either way. Now, I find that most students tend to prefer this method when they go to it, and they're like, wow, this looks like just extra work, which it probably is. And it's just easier to just look at it and apply which one of these where you want them to be positive. Seems to be the best way to go. So what winds up happening is you tend to overlap these questions with all sorts of issues now, and you've got exponents to exponents and positives and negatives, and it's like, well, how should I be doing this? So I wanted to show you a couple approaches here, just some more reps here just to show you what you could be thinking. So on this one here, I'm just going to show you all the different ways we could approach this. So our top one here, let's be a rule follower. So the rule follower, you just say, okay, x cubed over x to the 7th. And actually, I think I'll just do this on this one. You could have just said, well, I don't have any idea how this all works, but I do know what this means. It means that I've got 3 x's on the top, and I've got 7 on the bottom. I think I need one more here. And I'm just going to cancel. I've got 3 of them here, and I've got 3 of them here, and it looks like that's going to result in 1 over x to the 4th. That would be a pretty inefficient way to do this, but it gets you the right answer. I'm going to continue here, but now I'm going to follow the rule. So what if I would have looked at this and I would have said, okay, starting over, let's just start over here. Let's say we had x to the cubed over x to the 7th. And we said, all right, I'm going to follow the rule. X to the 3 minus 7. And you said that's x to the negative 4. And then you said, well, that's going to be 1 over x to the 4th. I'm going to move it to the denominator. Totally legit way to go. Okay. Versus if you would have looked at this and said, wait a second, it's bigger in the bottom. I think it's just easier to go 1 over x to the 7 minus 3. And that's 1 over x to the 4th. Okay, same answer either way. And this is where you start noticing you're getting a lot of nuance and variation. You just want to do the thing that resonates with the way you're wired. All right, let's look at these two. These are kind of weird. What happens if one of your exponents is negative? Well, let me show you how this is kind of strange. If you wanted, you could say the following. You could say, well, wait a second, I hate negative exponents. I like to move them where they're positive. And you just say x to the negative 2, that's going down. And you just say that's going to be x squared, x to the 6th. And you look at that, you say I'm multiplying, my bases are the same, add your exponents, 1 over x to the 8th. Got it. Totally legit way to go. But maybe you look at this one and you say, I'm following the rule, and I'm going to say this is x to the negative 2 minus, and you say minus 6. And then you say, well, that's x to the negative 8. And then you say I have to move that back down, 1 over x to the 8th. Totally legit way to go. But there's even a third way. What if you said, oh, it's bigger on the bottom? Look at this. This is kind of funny. You can say bigger on the bottom. That's going to be 1 over the x to the 6th minus negative 2. And that's going to give you 1 over x to the 8th. Okay? I'm not a huge fan of the bottom way because it's so easy to make mistakes with negatives when you're subtracting. This can sometimes be problematic. I tend to be a fan of going to where it's bigger or make everything positive either way, but both of those would be fine. All right? And then our last example, last set of 3 here, I want to do this approach again to show you how different these could be. What if they were both negative? Well, the first one, you might be this kid. You might say, both negative? Crazy, I'm moving them where they're positive. And your first move would be, I'm moving x to the negative 7 to the numerator. I'm moving x to the negative 3 to the denominator. And then you're like, oh, it's bigger on top. This is going to be x to the 4th. Done. But if you wanted, you could follow the rule and you could say, well, this would be x to the negative 3 minus a negative 7. Minus a minus would be a plus, and you would then get x to the 4th. That's true. But then let's say you felt like moving it to the bottom for some reason. Still works, but it's kind of weird. And you could say, oh, well, this is x to the negative 7 minus a negative 3. And you could say, oh, well, that's going to be 1 over x to the negative 4. I have to move that back up, and you could get x to the 4th. So why does a lot of students get confused on exponents? Well, there's so many different ways to do them. And we like to do them the most efficiently, but sometimes the most efficiently isn't the way that resonates with you the most. So on this one, I would say I like the top way first. Yeah, get them positive and then reduce. Or I would probably just go there, and then I decide which one's bigger. So you get an example of how these start layering in the complexities, and you have all of these rules to keep straight. So that is the division section. There's no substitute for reps, so make sure you're taking your homework seriously and coming in for extra help. There's no possible way you could do every type of exponent example in a video lesson or on a homework, so you really got to get in as many reps as you can with all the twists and turns that these can take. All right, so thanks for watching, good luck, and we will see you next time.